Alright, metric staircase conversions. We're going from 1,234.56 kilograms into centigrams. So I'm going to write this number, 1,234.56. Hey, it's a number. And then we're going to go from kilograms to centigrams. So I'm going to go 1, 2, 3, 4, 5 steps, and I'm going to the right. So I'm going to take this decimal place and I'm going to move it 5 steps to the right. 1, 2, 3, 4, 5. Now these can't stay blank, we have to put zeros in there. 1, 2, 3. My new decimal place is at the end. So this becomes 123,456,000 centigrams. To go from microseconds to seconds, we're going to go from here to our base unit, which is seconds. So that is 1, 2, 3, 4 steps. So I'm going to take that decimal place, I'm going to move it 4 steps. 1, 2, 3, 4. It's going to be a really teeny number. And so on and so forth. Next one, we're going from milliliters to decaliters. Pay attention, this is a capital D. So we're going to this side. Milliliters to decaliters is 1, 2, 3, 4 steps. And we've gone to the left. So I take this decimal place and I move it 4 steps to the left. 1, 2, 3, 4. So it's going to be 0.053019, so on and so forth. Next one, from meters to millimeters, we start here at our base unit, and we're going to go just 3 steps. 1, 2, 3 steps. So the decimal place is going to move to the right 3 steps. So I'm going to go 1, 2, 3. 4,691.7 millimeters. Alright, let's use some dominoes to go from 40 weeks into hours. So we start with a domino that says what we started with. They gave us 40 weeks, so that goes here. Now we need to go smaller than a week. I know that there are 7 days in 1 week. I've arranged my domino this way so that weeks are on top and bottom here. That way they cancel out. So now I'm in days. That's not where I want to get. I want to get to hours. So I know that there are 24 hours in 1 day. So here days have finally canceled out. I'm left with hours, which is what I wanted. So I take 40 times 7 times 24. That gives me 6,720. And then I multiply the bottom. 1 times 1 is 1. Simplify that fraction. Gives you 6,720 hours. So this just demonstrates that there are multiple ways to go about it. I could go from kilometers to meters. Kilometers have canceled out, now I'm in meters. Meters have canceled out, now I'm in centimeters. Get rid of centimeters. Now I'm in inches where I wanted to be. Simplify the fraction. So 2 times 1,000 times 100 gives me 200,000. 1 times 1 times 2.54 is 2.54. Simplify it, gives me about 78,000 inches. You could also do it this way. Kilometers to miles. Cancel out the kilometers. I'm left with miles. Cancel out the miles to get to feet. Cancel out the feet to get to inches. And I get about 78,000 inches again. Now, why are these two numbers different? Just because the conversion factors that we have are not perfect. This 2.54, that's a rounded number. 1.609, that's a rounded number. So just a little factor of rounding, but we're still at about 78,700 inches. Next we'll do a 2-unit problem. So I've got miles per gallon, and I'm going from kilometers to 2 kilometers per liter. So start with what I know. I've got 13 miles per gallon. I got to get rid of miles. So I put miles on the bottom here, and I look at my conversion table, and I find that 1 mile is equal to 1.609 kilometers. Now I need to get rid of gallons. I know that 1 gallon is equal to 3.79 liters. I need gallon on top here, and on the bottom here to cancel out. So now when you look at your units, I'm left with kilometers per liter, which is exactly what I wanted. So multiply the top 13 times 1.609 times 1 gives me 20.97. 1 times 1 times 3.79 gives me 3.79 liters. Simplify that fraction. You're left with 5.5 kilometers per liter. Next 2-unit problem, we're going from 9.8 meters per second into miles per hour. So start with 9.8 meters per second. It's already in a fraction form, so I'm going to leave that as my first domino. Then I need to get rid of these meters. Go to something bigger. So I'm going to go from meters to kilometers. Meters cancel out. Now I'm going to go from kilometers to miles. kilometers on top and bottom, so it cancels out. 1 mile is 1.609 kilometers. Then I need to get rid of these seconds here and change them into hours. I'm going to go one step bigger. I know that there's 60 seconds in a minute. Top and bottom cancel out. Now I'm left with miles per minute. So I need to cancel out minutes. 60 minutes in 1 hour, so the minutes cancel out. Now my only units left are miles per hour. So I multiply across the top. 9.8 times 1 times 1 times 60 times 60 gives me 35,280 miles. And then 1 times 1,000 times 1.609 times 1 times 1, 1,609 hours. Simplify that fraction down, you get 21.9 miles per hour. Alright, so for this one we are looking for speed, so we use our magical math triangle. We get rid of speed, and it shows us that it's distance over time, so speed equals distance over time. I've got 1.5 miles, and then I came up with this number 0.04 hours. How did I get that? Well, first I needed to convert 2 minutes 24 seconds into hours. So 2 minutes is 120 seconds, plus 24, that gives me a total of 144 seconds. And then I do my dimensional analysis to get seconds into minutes, and minutes into hours, gives me 0.04 hours. So then all I have to do is 1.5 miles divided by 0.04 hours. This horse was running at 37.5 miles per hour. He's the fastest horse alive. Problem 2 is looking for time, so we cover up that. It tells us that our formula is distance divided by speed. So my distance is 17 miles, my speed is 2 miles per hour, and that gives me a total time of 8.5 hours. This one's much simpler. Number 3 is looking for distance. So I scratch out distance. That tells me my formula is speed times time. So I'm going to take 8 meters per second times, where did I get that? It says that he was traveling for 1 hour. That's equivalent to 3,600 seconds. 1 hour times 60 minutes in an hour times 60 seconds in a minute, 3,600 seconds. So 8 meters per second times 3,600 seconds gives me 28,800 meters. Now you can use your metric staircase and simply go 1, 2, 3 to move it into kilometers, or you could use the fact that there are 1,000 meters in every kilometer. Doesn't matter, however you do it, you're going to get 28.8 kilometers for the Hogwarts Express. Alright, so here's a racehorse. When we say go, everybody starts their timer here at 0. When they pass the first pole, timer says 24. Second pole, 41. Third pole, 58. We know that they're going to have this really fast burst of acceleration here. Then they're going to start accelerating a little bit less, and then finally they're going to start nearing their top speed. They really can't increase much more than that. And finally at the end they might slow down actually a little bit. So let's see how that works. So here's our start times. Let's figure out our velocity. Velocity is total distance divided by time. So here's my total distance, here's my total time. Divide 200 by 24, gives you 8.3. 400 divided by 41 seconds, 9.7. 600 meters divided by 58 seconds gives you 10.3. So this is how fast he was going, then this fast, then this fast. He's getting faster, but by how much? Acceleration is your change in velocity divided by your change in time. So here, my velocity went from 0 to 8.3. That's the top half. My time went from 0 to 24. Here's your bottom half. You simplify that, gives you 0.34 meters per second per second. Every second that horse was increasing speed by 1/3 of a meter per second. For the second interval, we take our change in velocity, 9.7 minus 8.3, so how much faster did he get, divided by our change in time. So we've got 9.7 minus 8.3 divided by 41 seconds divided by 24 seconds. Simplify that down, it gives you 0.08. He's not accelerating nearly as fast. He's going faster, but he's very, very gradually increasing. And then here at the end, you've got 10.3 minus 9.7, 58 seconds minus 41 seconds. Simplify that down, 0.03. He's barely increasing in speed, but every second he is getting a little bit faster, just like what we saw over here. Last nerdy example, we're trying to figure out who's going to win, the Enterprise or the Falcon. Sorry, Enterprise or the Falcon. So we know our formula for